Okay, so a few things before we go ahead and actually get to the unit circle. One, don't forget, in a couple of days, you've got your next quiz, which is going to be over the lesson that we just wrapped up, the lesson over which you currently have your homework assignment, which is due tomorrow. So tomorrow we'll come in, we'll grade it, talk about any questions, and we'll actually push on with the lesson involving the unit circle. Today is just the introduction. I want to make sure you know the patterns and how to recreate it yourself. The big one, of course, is coming up next week, Thursday the 25th. That's going to be your second exam. So we definitely want to be looking ahead to that, prepare for it. It will absolutely have material from your homework. Okay, linear and angular velocity, area of a sector, arc length, but it's also going to have elements from the unit circle and the lesson that we're going to push on with tomorrow. Okay, so as we get closer, I'll be able to go ahead and tell you more about that. But you do have a 3-day weekend this weekend, so you would be in school anyway, so perfect opportunity to go ahead and pull out your notes, right? Yay, okay, so there you go. But anyways, unless there's any other questions. One thing about this morning, I do apologize to anybody who came in. I left yesterday thinking that I was not having to go to a meeting this morning, and I came in and was told you really need to be there. So it was beyond my control. I apologize about that. So hopefully nobody showed up and just waited for me. But I know that tomorrow was going to be the deadline for the test retake. So I'm going to go ahead and just extend it to another day because I didn't have any control over it in case anybody did show up. So it's not tomorrow morning. You now have until Thursday morning if anybody wants to retake, so you have a little bit of extra time. Now, as far as those happy minutes goes, one other thing, can you retake those? Absolutely. In fact, since yesterday when I started, I've already done 2 retakes. So at any time, you'll just come in and we'll go ahead and either work the same thing, or when we get to the math, you'll probably work something very similar. So yes, please, please, if you want to retake those, come on in and let's get that taken care of. All right. So let's talk about the unit circle. A little bit of background information first. The unit circle is a circle centered at the origin. Okay, so 0, 0. With a radius of 1, and that's why we call it the unit circle, because the radius is just 1 unit. Since the equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center of a circle and r is the radius, well, then we're going to go ahead and say that the equation would be x squared plus y squared is equal to 1. Or some people do like to go ahead and incorporate the zeros if they're part of the center. So you can either say, x plus or minus 0. I usually say minus. X minus 0 squared plus y minus 0 squared is equal to 1. That's also equivalent. Okay. Some people like to show the zeros. Some people don't need to. All right. The circumference of a circle is found by using the formula C equals what? And there's actually 2 versions of it. Pi times the diameter, so that's one of them. And then the other one is 2 pi r. And we're going to go ahead and focus more on the 2 pi r because we've been talking about radians, and 1 full revolution, again, as we're about to see, is 2 pi. So because the radius of the unit is equal to 1, 2 pi times 1 would give me a circumference of 2 pi. And we actually talked about that in one of the beginning lessons for trigonometry. Now, when measured in degrees, 1 full revolution of a circle is equal to 360 degrees. If we split the circle into 4 equal parts, then at each corner the angles go up by 90 degrees. These are referring to the axes. Okay. If we split the circle into 8 equal parts, then from one point to the other we would need to apply 360 divided by 8. 45. And if we go ahead and split the circle into 12 equal parts, then from one point to the other, we would need to add 30 degrees. Now, the one thing that's really going to help us when we get to the radians on the unit circle is going to be multiples of 45 and 30. Okay, but don't want to get too far ahead of myself. Here's our unit circle. So this one here, I went ahead and printed it on cardstock, and I made it a very bright color so that you can easily tell where it is in your notes. And it's going to be much more durable because you're going to want to hang on to this for a long time. I would say probably until the end of the school year. Now the other one, this one's just on normal paper. I would really encourage you in the next couple of days take 5-10 minutes. You need to see if you can recreate the unit circle without your notes. You need to recreate it just based on what you know about the unit circle. And you're going to want to get better at that. In fact, one of the happy minutes we're going to have eventually is probably to recreate the unit circle. Okay, so I'll give you a little more time, but on quizzes and tests, I won't be providing that to you. So you are going to have to create it and then use it to answer questions. Okay, so just kind of giving you, foreshadowing what's going to be happening. Okay, so here's our unit circle. Let's go ahead and start. There's 3 parts you really want to fill in: the degrees, then the radians, and then the points. There are only 16 points on the unit circle that at first we're really going to be interested in, and basically because of reference angles. Okay, and I'll remind you about what those are in just a minute. But as we move forward, everything we're going to come to know about trigonometry won't just apply to these 16. You can apply it to any point on a circle, and it could be any size circle that we come across. The radius doesn't always have to be 1. This is just the foundation that kind of sets it all. So let's go ahead and start with 0 degrees. Let's get our degrees down. Now, we were talking about dividing this into fourths. So what is 1/4 of 360? 90. So we know that would be 90. Half. 180 degrees. 3/4. 270. And then I get all the way back around to 360 degrees. Now that we're already accustomed to because we've been plotting some terminal sides, things of that nature. Okay. But now you'll notice while that takes care of 4 of the 16, each of the 4 quadrants has a cluster of 3 points right in the middle. Now these points, they're equal distance from each other, equidistant. Okay. From each other, they're 15 degrees, but from the axis, they're always going to be 30 degrees off of that. So if I start here in standard position and I begin to rotate, this one right here is 30 degrees. The point closest to an axis is always 30 degrees away, but the cluster, they are 15 degrees away from each other. So what would this middle one be? This would be 45 plus 15, 60. And now you'll notice plus 30 gets me to the next axis. There's my 90. And now I'm going to add 30 again to get to the first point, which would be 120 plus 15, 135 plus 15, 150, and then add another 30, get back around, you're at 180. And right there, we're already halfway done. And then we just keep that pattern going. And that's really what's going to help you on the unit circle, knowing those patterns. Okay, so what would this next one be? That would be 210, 180 plus 30. 210 plus 15. 225 plus 15, 240. Now plus 30 to get to the next axis, 270. So add 30 again off of it. 300. Then what? 315, 330, and then plus one more 30 gets me all the way back around to 360. Okay, so the unit circle, as we're going to come to understand it, we're going to be very, very interested in these 16 points. Okay, but eventually we're going to be able to expand it to anything on the circle. Okay, it's just going to take us a little while to get there. So typically nobody has really any problems with the degrees. Any questions on that? Okay, the closest point to the axes are 30 degrees off of those. The cluster are 15 degrees from each other, all the way around. Okay, now let's go ahead and get to the second part, the radians. Okay, now we know how to take a degree measure and rewrite it as a radian. How do we do that? We multiply by 180 is part of it. What over 180? Pi over 180, right? Okay, so that's easy enough. We've seen it quite a bit. But you probably don't want to go ahead and do that because it's going to get time consuming. And we want to be able to do this as quickly as possible. So again, patterns. If your degree measure is a multiple of 30, you're going to count using 1/6. Okay. If it's a multiple of 45, you're going to count using multiples of 1/4. Okay. So let's go ahead and start off with the easy one first. If it's a 45 degree multiple, we're going to count by 1/4. All right. So think about it. 1/4 pi, well, that's just pi over 4. Okay. Now the rest of this is going to start to fill in, and you're going to recognize a lot of it. Okay, so after 1/4 pi would come 2/4 pi, right? Well, what's the next multiple of 45? 90, right? So this would be 2 pi over 4, but what do you notice? Yeah, that's just pi over 2. And we're accustomed to seeing that on a circle. Okay. So I went 1/4 pi, 2/4 pi. Now the next multiple of 135 would be 3/4 pi. And see, then we get to halfway where you would have 4/4 pi, but what's 4 divided by 4? Yeah, so you just have pi. So see, we don't have to sit here and convert every one of these. We don't even have to memorize it. Okay, I'm just counting by fourths. So we've done 1/4 pi, 2/4 pi, 3/4 pi, 4/4. What's next? 5/4. Okay, then next. 6/4, right? But what's 6/4 reduced to? 3/2. 3 pi over 2. And see, we're accustomed to seeing him there. Then what's next? What number are we on? 7 pi over 4. And see, I get all the way back around to 8 pi over 4, but what's that? That's 2 pi. That's 1 revolution. Okay. We also start at 0 radians. And there we go. Okay. So if it's a multiple of 45, count by 1/4. Okay. Just all the way around. Does anybody have any questions about that? Now, if it's a multiple of 30, we count by what? Does anybody remember? 1/6. Okay. So this first 30, I'm going to say 1/6 pi, or pi over 6. And you could take any of these degree measures, multiply by pi over 180, and see that we are getting the correct radian equivalent. So after 1/6 pi would come 2/6 pi, but that's pi over 3. So some of them do need to be reduced. You do want to reduce it. You want to leave it as, 2/6 pi. Then what? 3/6 pi, but 3/6 is the 1/2 that I already have. So we've done 1/6 pi, 2/6 pi, 3/6 pi. What's next? 4/6 pi, which would be 2 pi over 3. What about for 150? Okay, 5/6 pi, or 5 pi over 6. And then see the same thing that happened with 180 where we had 4 pi over 4. See, now we're to 6 pi over 6. So again, we have pi. So what number are we on? 7 pi over 6 for 210 degrees. 7 pi over 6. 8 pi over 6, but what's that? 4 pi over 3. 9 pi over 6, but 9/6 is 3/2, which I already have. Now, what number are we up to? 10. So what's 10/6? 5/3. So this is 5 pi over 3. 330 would give me 11 pi over 6. And then see, just like previous, where we had the 8 pi over 4, now we're getting to 12 pi over 6, but that's still what? See, again, it's still 2 pi. So right there, we've got 2/3 of the unit circle filled in. We've got the degrees and we've got the radians. Okay. Again, patterns. Now, some people in other classes have already mentioned they're just going to go ahead and commit the entire unit circle to memory. And you are more than welcome to go ahead and do that. If you feel that's the best way, please, go ahead and do so. Even I don't have it memorized because I don't really think it's necessary. You see, I don't even have my notes with me. I'm just going from the patterns. If you understand the patterns, you don't need to memorize it. Okay. So now all I have left, I want to go ahead and know the coordinate of each and every one of those 16 points. Now 4 of them are going to be really simple. Why do we call it the unit circle? Because the radius is 1, right? It's 1 unit. So this is my origin, okay? Because this would be the x and the y axes. So this radius right here is equal to 1. So the quadrantals here, like that point, well, what would be the coordinate of that point? If I'm going from the origin and I want to go to this point, I would move horizontally how far? 1, but then I don't move vertically, so that has a coordinate of 1, 0. And I mentioned the term quadrantal. What does that mean? Aiden? There you go. If your terminal side where you stop rotating, if it stops on an axis, that's a quadrantal. So we have 4 of those here. The other 12, they are not going to be quadrantals. Okay, so this one right here at 90 degrees pi over 2, what would that coordinate be? That would be 0, 1. At 180 degrees pi, negative 1, 0. And then down here, 273 pi over 2. 0, negative 1. There we go. So right there, you've already got 4 of the 12, or 4 of the 16 done, excuse me. There's 12 left. All right. How are we doing so far? Anybody confused? Okay. Now, we're going to go ahead and start looking at these cluster of points in each of the 4 quadrants. And there's different ways that you can do them. I'm going to go ahead and start by the most basic method, triangles. If I take each of those points and I go ahead and create a segment perpendicular to the x-axis, it's going to create a bunch of triangles, specifically 12 of them. But there's some really good news here. It's only the same 2 triangles repeating over and over again. The ones in red are a 45, 45, 90 triangle. Okay? The ones in blue, those are a 30, 60, 90. Okay? So if you realize that it's just the same triangle over and over and over again, the side lengths don't become an issue. In fact, let me go ahead and take a look at this guy right here. Let me highlight this one. So here's a right triangle. Now we rotated up. Remember, this one was 60 degrees. So this base angle is 60. This is 30. Now, what's directly across from 30? One half, right? Remember, it's going to be the same triangles over and over again. What's across from 60? Square root of 3 over 2, and we have a radius of 1. Now remember, if you ever forget, we know that the hypotenuse is 1, so you can work backwards off the special right triangles and easily get the 1/2 in the square root of 3 over 2. Now let me go ahead and show you something else. There's symmetry all throughout this circle. I can take this triangle that I have here, and I can reflect it across the y-axis, so that I have this guy right here. Okay, so this would once again be 60 degrees. This one would be 30. Now what's across from 30? 1/2. What's across from 60? Square root of 3 over 2, and then you have a hypotenuse of 1. But I'm forgetting something. This is what you got to be careful about. What quadrant am I in? I'm in the second quadrant. What's negative in the second quadrant? X or Y? X. So I'd want to make sure to have a negative on that 1/2. Now, I'm not saying that the base of this triangle has a length of negative 1/2. The negative is simply telling me the direction I would have to go from the origin. See, from the origin, if I go right, positive. If I'm going to go left, then it's negative. That's the only thing you got to be careful of. So in quadrant 3, both X and Y are negative. In quadrant 4, what? X is positive, Y is negative there. Okay, so let me go ahead and show you quadrant 1 using these triangles. So let's say I want to know the coordinate right here at 30 degrees, pi over 6. So I'm going to go ahead and drop a segment right down. I'm going to create a right triangle. Now, because we rotated 30 degrees, that's my base angle. That's 60. Well, if it's a 30, 60, 90 in the unit circle, it's the same size over and over again. What's across from 30? 1/2. What's across from 60? Square root of 3 over 2. And then the hypotenuse is always 1 because we're in the unit circle. So just think, if I were going to go ahead and plot a point. If I were starting here at the origin, I'd want to go right and then up to get to this guy right here, right? So what would the coordinate on the circle be at 30 degrees? How far right did I go? Square root of 3 over 2, comma, and then how far up did I go? 1/2. That would be the coordinate of the point on the circle right there. Okay. And then for the next one, 45, I'm going to do the exact same thing. I'm going to drop a perpendicular segment down. Here's my triangle. Well, this would be 45. This would be 45. Does anybody remember from the other page, or if you're just working it out, what would the side lengths be? Just square root of 2? Square root of 2 over 2. So I'm using the exact same idea. I use that point to create a right triangle. Now from the origin, I want to move right, and I want to move up to get to that point right there. So what would that coordinate be? Square root of 2 over 2, square root of 2 over 2. Okay. Now, let's do another one. I want the coordinate at 60. So I'm going to drop a segment straight down. That's my 90-degree angle. Here's the triangle. But what's this base angle this time? This isn't 30. This is 60 because remember, that's where I stopped rotating. This one would be 30. What's always across from 30 in these triangles? Okay, half. Across from 60. Square root of 3 over 2. And across from 90, we have our radius of 1, the hypotenuse. So what's the coordinate at pi over 3 radians? How far right did I have to go? 1/2. And then up square root of 3 over 2. Okay. Now, just like I said a moment ago with all these triangles, I mean, you can continue to do this over and over again. We are definitely not going to do all 12 because I don't think that's necessary. But let's start looking at symmetry. If I were to take this triangle that I was currently working on and I just reflected it across the y-axis, okay? So this would be 60. This would be 30, okay? Across from 30 is always 1/2. Across from 60, square root of 3 over 2, with the hypotenuse of 1. But what am I forgetting? 1/2 has to be negative because x is negative in the second quadrant. Okay, so I'm doing the same thing. I want to go from the origin here. I want to go left and then up to get to this point. So what would the coordinate be? Negative 1/2. Square root of 3 over 2. Now, see, you can continue to go ahead and use triangles over and over again, okay? But now start to use the symmetry. How did this point right here change to that point when I reflected it? The only thing that changes the x value got negative. So just do the same thing for the other 2 points. The one right here at 45 degrees, I reflected over, it's going to correspond to 135. So he should be negative square root of 2 over 2, square root of 2 over 2. Do the same thing for the 150. What would he be? Negative square root of 3 over 2, 1/2. Okay, let me go ahead and take these out. Is everybody seeing how I'm getting these points? Okay. Now, let me go ahead and show you one more. Let's say I want the coordinate at 7 pi over 6, 210 degrees. Well, I'm going to create a perpendicular segment. Now, this is why the reference angles are going to come in and be very, very important to you. What's a reference angle? There you go. It's the angle created between the terminal side where you stop rotating and the closest x-axis. So this guy here, we rotated all the way around to 210. So what's 210 minus 180? 30. So there's 30. This is 60. Across from 30 is 1/2. Across from 60, square root of 3 over 2. And we have a radius of 1. What am I forgetting? Okay, here both x and y are negative. So this point should be negative square root of 3 over 2, negative 1/2. Now you'll notice 210 is going to correspond to 150. You see how I took 30 and I just reflected it over the y-axis? Well, now I'm going to take these points here in the second quadrant, I'm going to reflect them over the x-axis. So how did this point here from 150 change to 7 pi over 6? What happened? Susan? Now the y is negative. So do the same thing for the others. The 225 is going to correspond to 135. So what would his point be? Okay, can't hear you. What would the coordinate be? For 225 degrees. Negative square root of 2 over 2. Negative square root of 2 over 2. And for the last one in quadrant 3, 240 would correspond to 120. So what would that be? Negative 1/2, negative square root of 3 over 2. There we go. Now do the same thing. Take about 30 seconds if you haven't already done so. Finish up the coordinates in quadrant 4. Now you can do this however you want. You could take the points that we now have in quadrant 3 and reflect those across the y-axis. Or I could take the same points from quadrant 1 and reflect those across the x. However you want to go ahead and do that. Okay. Okay, so how about we start with Jane? What would be the coordinate at 5 pi over 3? There she goes. She says 1/2 negative square root of 3 over 2. Perfect. Okay, Raphael, what would be the coordinate at 315 degrees? Root 2 over 2, negative root 2 over 2. Okay. And then 330, let's finish it up. Ethan. And there you go. That is your unit circle. Okay, with all three parts. We got the degrees, we got the radians, and we have the 16 points, the coordinates. Okay. Any questions? Okay. So you can either create the points using the triangles, the same triangles, special right triangles that are going to show up over and over again. You can go ahead and use symmetry. Okay. There's another way, and I always wait till the end to show folks this. Now, I'm about to erase this unless anybody has any questions. It did take us a while to get here. Everything came full circle. Really? Okay. So I'm going to go ahead and take this out. Now, let's go ahead and focus on just one quadrant. Let's say quadrant 1. Because if you have one quadrant, it stands to reason that you can get the other pretty easily, right? Just by reflecting it. Okay. So let's start here. We have 0 degrees, 0 radians. We have 90 degrees, which is also pi over 2 radians. All right. This one here was what? How many degrees? 30. It was 30 degrees off an axis, but these in the middle were 15 off of each other. So that's 45, that's 60. If it's a multiple of 30, we're going to count by 6. So this would be 1/6 pi. This would be 2/6 pi. If I could write this. If it's a multiple of 45, you're going to count by 4ths. So pi over 4. Okay. Now, if it's a quadrantal, those are going to be easy. This is 1, 0. This is 0, 1. That's no problem. But let's say within seconds, you want to go ahead and get those 3 coordinates. You don't want to use a triangle, or you don't want to use any other method. Take a look at your paper. Do you notice anything that all 3 of those coordinates have in common? In fact, all 12 inside of the quadrants? What's the one thing that they all do? That's exactly right. Jack says they're all divisible by 2. So let me go ahead and set this up. I'm going to say over 2. Okay. So every single one of those values, whether x or y, positive or negative, they're always being divided by 2. Here's the shortcut. If you start on the inside and you count down, 1, 2, 3, 1, 2, 3. Now take the square root of each numerator. But what's the square root of 1? 1, so you don't have to do it. So square root of 2, square root of 3, square root of 2, square root of 3. Okay, so now in seconds, you've got the first quadrant, which can give you any other quadrant you want. Okay, even if you don't want to fill in the entire unit circle, let's say I want to know the coordinate of this point right here. And again, just use symmetry, because this reference angle right here was 30. That means this one has to be 30, so we're at 150. Am I counting by 1/6 or 1/4? By 6. So this would be 5 pi over 6, because I know the very next one would be 6 pi over 6. But this point here reflected, negative square root of 3 over 2, 1/2. Okay. See, it's not about memorization. It's just about knowing the patterns. If you know those patterns, you should be able to knock it out pretty quick. Hey, Jack.
Even knowing the patterns, though, like just writing all of this, I feel like would take more than a minute.
Oh, yeah, you're going to have more than a minute, but there will be time limits. And you know, when you're given a quiz or a test, those are going to have time limits as well. So that's why I'm going to also post this to the website. Okay, I gave you an extra copy of this. You know, I'll try to have even more copies tomorrow, but don't wait on this to practice. Like I said, in the next couple of days, you know, not right away, okay, but definitely in the next couple of days, see how far you can get just based on the patterns, okay? And it's just like those happy minutes. What's going to happen the more you do it? Yeah, you're going to get better. You're going to get faster. And that's just what has to happen, okay? How are we doing? Any questions? Okay, and that is all I have for today. That is the unit circle. Tomorrow we will start with the actual lesson, and we'll really start to work with this guy. Okay.